let's quickly observe properties of conjugate. So you don't need to memorize, but it's good exercise to understand conjugate concept. So number one, if I have complex number and then I conjugated it, and then I decided to conjugate again, what do you have?
C.
Just itself, right? So when you double conjugate it, it comes back to yourself. Very good. Number two, when you have some kind of complex number and then add to another complex number and then put conjugate, then it's the same with conjugating separately and adding them together. Well, you can also do it with negative signs. So let's prove it. I think we need to prove this one. Proof. Let Z1 is a plus bi, and then Z2 is a c plus di. Then Z1 plus Z2 conjugate is the same with a plus c plus b plus di, everything conjugated, right? Which means a plus c minus bi minus di, right? So what I am going to do, we want to achieve separating them. So I'm going to separate them a minus bi plus c minus di, which gives you the conjugate of each z1 and then conjugate of z2. You can prove it with minus signs as well. So if I just put minus signs here in red, it's going to be exactly the same proof, but thinking differently. So I have minuses here. So in that way, it's going to be pluses here, and then it's going to be pluses here. So, oh, sorry. What I meant is just putting opposite signs for each, like that. Oh, sorry. It doesn't change right there. Okay. So you can use for both plus and minus. So what we're talking about is if you add or subtract and then conjugate, it's the same with you separately conjugate and then add or subtract. Understood? Are you good?
Yes.
Okay. Please let me know if you have any questions or anything is confusing. Okay. Vicky, you might know all these contents anyways, right? You already have learned this.
No.
No? Okay.
No.
So you learned a little bit like more simplified version?
Yeah, I learned simplified version when I was in grade 10, and my math teacher in grade 10 didn't teach me that much.
Right. So we actually teach complex numbers first in grade 9 or 10, and then we intensify the level of complex numbers in pre-calculus. So pre-calculus complex numbers are so much more in depth and complicated and more interesting. Okay, so let's get smarter. One more. So now we're talking about product of two complex numbers. So I have z1 and z2 multiplied together, and then I decided to conjugate them. But it seems like the result is same with you conjugate them first and then multiplying later. It's the same with division. So if you take two numbers and then divide by one number and then conjugate, the result is the same with you conjugate first and then divide the second conjugate number by the first one. Oh, of course, the z2 shouldn't be 0 in this case, right? We're not talking about 0. It's all complex numbers. So it's going to be a little bit long proof, but we have to prove it. Let z1 is a plus bi and z2 is a c plus di, just like the above case. Guys, am I speaking too fast? Are you okay to write it down?
Yes.
Okay. Just let me know if I need to slow down or if you don't understand. Just give me feedback. I will adapt. Seems like Annie and Julie is gone. Technology issues. Okay, so we know that z1 times z2 is same with, let me start it actually down below. I want to start over right here. Okay, very good. Okay, so when you multiply them and then conjugate them, then it looks like a plus bi times a c plus di inside a parenthesis and the big parenthesis and the conjugate. So what happens, you have to expand inside of this parenthesis. So a times a c plus ADI plus CBI minus DB. Everything conjugate. Okay, I need it to be a little bit simpler. So I put those AC and then BD together, which is the real part. Okay, and then I have collection of complex imaginary part, AD plus BC multiplied by I. Everything should be conjugated now. That's not difficult. I just have to change the sign. So AC minus BD minus AD plus BC I. Okay, now what do I have? I have AC minus BD minus ADI minus BCI. So what I'm going to do is I am going to try to take AD plus BC in the middle and then put I there. And then I am going to put BD and I square because I square make it -1. Okay, so I isolate AC on the first part and then BD I square at the end and then put I parts, imaginary part in the middle. And then what you can do is you can factor it. Factor. So it seems like A times minus BI, C minus DI. You can factor them. So the conclusion is it's the same with Z1 conjugate times Z2 conjugate, right? So plus became negative. So conjugate first and then multiply. So you just proved it, right? Okay, number 4. One more, we don't need to prove it. I think it's more obvious, is real number. Okay, so A plus BI plus A minus BI, it gives you 2A, so it's real number. If we multiply a complex number by its conjugate, then it's also a real number. So A plus BI times A minus BI gives you A squared plus B squared. We talked about it before. So these are kind of properties of complex conjugate.